May 19th, 1944, near Cisterna di Littoria, 30 miles south of Rome. The sun had barely risen over the blasted Italian countryside, but the air already shimmered with heat and the sickly scent of cordite. Leutnant Karl-Heinz Brenner, 23 years old, and commander of a 3-gun battery in the German 71st Infantry Division, crouched behind a low stone wall, peering across a field littered with wreckage. The battle had ended the previous night. American artillery had torn apart their forward positions, forcing Brenner's men to retreat nearly 2 kilometers. Now, at dawn, he was ordered to assess what could be salvaged. Among the smoldering craters and shattered olive trees, Brenner's eye caught something that didn't look German, a gun shield of smooth steel, a barrel thick as his torso. Resting at an angle on a knocked-out Sherman tank, he approached cautiously. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The weapon bore the inscription, U.S. Army M2A1 105mm Howitzer. His gunner, Feldwebel Otto Küster, whistled softly. Amerikanische Artillerie, he muttered. Looks small for a heavy piece. Brenner didn't answer. He had read about this weapon in briefings, a divisional field howitzer, light enough to tow behind a truck, firing a 15-kilogram shell out to 12 kilometers. But this was the first time he had ever seen one intact. The breech mechanism gleamed as if it had just left the factory. Nearby lay 3 empty shell casings, stamped Lot 1944, Frankfurt Arsenal. He picked one up, marveling at the precision machining. "Sir," Küster said quietly, "the firing chart's still here." It was, folded neatly inside an oiled pouch attached to the carriage. Brenner scanned the figures. One note caught his eye. Maximum rate, 8 rounds. Per minute. He blinked. 8 rounds per minute. That was impossible. The German equivalent, the Leutnant, could manage perhaps 4 rounds at best before its crew overheated or the recoil mechanism faltered. 8 rounds per minute meant sustained, accurate fire industrial perfection in motion. That morning, Brenner would order his men to haul the gun back for study, and in doing so, he would open a window into a truth the Wehrmacht had never fully comprehended, that the war had already been decided not by strategy or courage, but by the mathematics of mechanical repetition. For the German artilleryman, the gun was the soldier's symbol of order, precision, and intellect. Artillery was called Gottes Hammer, God's hammer. Every strike, a test of calculation and discipline. German doctrine revered it as a science, yet what Brenner would soon learn was that science alone no longer decided victory. Production did. In 1939, when the Wehrmacht crossed into Poland, its artillery park was the most technically refined in Europe. The 10.5-centimeter Ley FH-18, introduced in 1935, embodied that refinement. It was heavy, nearly 2 tons, but accurate, rugged, and designed to be eternal. German engineers obsessed over metallurgy, over the life of the recoil buffer, the precision of elevation gears, but the same attention to perfection that made the gun reliable also made it slow to build. In 1943, German industry produced just over 11,000 field howitzers of all calibers. In the same year, the United States produced nearly 40,000 105mm howitzers and their spare barrels 3 times the German output, with thousands more being shipped to allies under Lend-Lease. Every one of those American guns was identical, a clone built to tolerances of a few thousandths of an inch, each interchangeable with any other. To German officers like Brenner, trained to believe craftsmanship equaled superiority, this mass identity seemed soulless. But what he now saw before him was not a product of laziness, it was the ultimate expression of efficiency. The M2A1 howitzer, standardized in 1941, was designed around 2 simple principles: speed of fire and ease of production. Its hydropneumatic recoil system allowed immediate re-aiming after every shot. The split trail carriage gave stability on soft ground. Its semi-automatic breech meant the next shell could be loaded before the previous casing had even stopped rolling away. A well-trained American gun crew could indeed sustain 7 to 8 rounds per minute for short bursts twice the German rate. That arithmetic difference, 4 versus 8, translated on the battlefield into annihilation. American doctrine emphasized fire superiority. Instead of conserving shells for decisive moments, they saturated the enemy with overwhelming barrages. In Sicily, in Italy, and later in France, German soldiers described the same phenomenon, a single battery of American 105 seconds, firing faster than an entire German battalion could respond. Leutnant Brenner's men had felt that the night before. They had counted the flashes across the valley dozens, hundreds. Impossible to tell where one battery ended and another began. And when the shells came, they came in rhythm, not sporadically, but continuously, like rain. The Wehrmacht, for all its engineering brilliance, had never prepared for that. By mid-1944, American factories were producing 24 million artillery shells per month. The German total, by comparison, had fallen to under 3 million. Brenner knew none of these figures, but he could sense the truth behind them. He could see it in the flawless machining of the captured Howitzer, in the smoothness of its gears, the ease with which its barrel pivoted, the ergonomic balance of its hand wheels. Everything about it spoke of abundance of a nation whose factories were not straining to survive but thriving in full coordination. He ordered the men to move the gun using captured American trucks, another irony, since the U.S. Army's standard 2.5-ton GMC truck had a towing capacity greater than most German tractors. The Americans called it the deuce and a half. The Germans called it, with grudging admiration, der Lastesel, the pack mule. By the afternoon, they had the weapon loaded and ready for transport to the division workshop. But the moment that seared itself into Brenner's mind came later, when one of his mechanics, Unteroffizier Max Reiner, insisted on test-firing it. They cleaned the breech, loaded a captured American shell, adjusted elevation, and pulled the lanyard. The recoil was smooth, the noise sharp but clean. The breech block slammed open automatically. Reiner grinned and shouted, "Noch einer!" Another! They fired again. And again. In 1 minute, they fired 8 rounds. The gun did not shake, taking itself apart. It did not overheat. Brenner stared, expressionless. The rate of fire his manuals declared impossible was being demonstrated in front of him by a machine built on the other side of the Atlantic. In that moment, standing amid the olive trees of Lazio, he realized that the enemy's real weapon was not ingenuity but volume, the power to make a perfect thing, not once, but 10,000 times over. The German army prided itself on tactical virtuosity, on cleverness and precision. Yet, against a weapon like this, reproduced endlessly, supplied effortlessly, all cleverness was ash. That night, as the division prepared to fall back again toward the Alban Hills, Brenner wrote a brief note in his logbook. The American 10.5 gun fires as fast as a machine gun. We could never match this tempo. Our gunners are craftsmen. Theirs are workers, but their work wins wars. The sentence would never be read by anyone until decades later, when his notebooks were recovered from an Austrian farmhouse. But his reflection captured the silent collapse of the German martial myth, the belief that discipline and engineering genius could overcome industrial arithmetic. For every captured howitzer like the one Brenner studied, hundreds more stood behind American lines, ready, supplied, and fed by a system whose logic the Wehrmacht could no longer comprehend. The story of that weapon, the M2A1, was the story of the American way of war, a fusion of simplicity, speed, and mass that turned artillery from a craft into an industry. And for the German soldiers who first encountered it in the fields of Italy and later in Normandy, the shock was not merely technical, it was existential. They had been taught to see themselves as the inheritors of Frederick the Great's artillerymen, masters of ballistic tables and elevation angles. Yet when faced with a weapon that could deliver twice their firepower with half their manpower, they felt something deeper than fear. They felt obsolescence. The captured M2A1 would be shipped north to a testing ground near Verona. There, German ordnance specialists from Heereswaffenamt Section 4 would disassemble it piece by piece. Their report, filed in July 1944, survives in fragmentary form in Bundesarchiv records. It concludes with a sentence that, in retrospect, reads like a eulogy for the German art of war. The American 105mm howitzer represents not technical superiority in design, but superiority in method. It is the product of a nation organized for quantity, and in this lies its greatest strength. That was the moment when Brenner and thousands like him began to understand that no matter how bravely they fought, the war was being decided in the furnaces of Detroit and Pittsburgh, not in the forests of Italy or the hedgerows of Normandy. Yet the story doesn't end there. For in the weeks that followed, as Brenner's division retreated northward, they would encounter the M2A1 again, this time not as a captured relic, but as a storm of shells falling from invisible guns miles away, fired by men who had never seen their targets yet who could hit them to within yards every time. And soon, the same psychological rupture that Zimmermann had felt dividing cigarettes, or that German prisoners at Castle Itter had felt fighting beside Americans, would reach the artillerymen too, the dawning realization that they were fighting an enemy whose weapons industry embodied the very principles they had once believed defined themselves: precision, efficiency, discipline. It was a reversal so complete that even in defeat, it forced a kind of respect and, in some, quiet admiration. By early June of 1944, the M2A1 105mm howitzer, captured by Leutnant Brenner's unit, had reached the German army testing ground at Verona, designated Heeresjugend Italien Süd. The facility, hidden behind railway sidings and olive groves, had once belonged to the Italian Royal Army. Now it served as the southern outpost of the Heereswaffenamt, the German Army Ordnance Office. A team of engineers, most of them exhausted veterans of the Russian front reassigned after injuries, gathered around the unfamiliar gun as it was rolled into the courtyard. The weapon looked deceptively simple: a compact barrel just over 2 meters long, mounted on a split trail carriage with pneumatic tires. Its breech block was semi-automatic. When the gun fired, the block opened by itself, ejecting the casing with a metallic hiss. One of the examiners, Oberingenieur Friedrich König, a mechanical engineer from Düsseldorf, who had spent years refining the recoil systems of the German LFH-18M, took one look at the weapon and said quietly, "It was built by a factory, not a gunsmith." That was not an insult, it was recognition. German artillery design philosophy before the war had been shaped by two constraints: the limitations of raw materials and the traditions of craft engineering. Every gun was assembled with meticulous hand-fitting, each component individually adjusted. This produced weapons of exquisite precision, but also of maddening inconsistency when it came to replacement parts or field repair. The American howitzer was the antithesis of that philosophy. Koenig's team discovered that every bolt, every fitting, every hydraulic seal bore a serial number, but followed universal dimensions. Components were interchangeable between different guns. In one experiment, a recoil cylinder from a separate M2A1, captured near Anzio, fitted perfectly into Brenner's Verona gun, without the need for adjustment. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. For Koenig, it was a revelation. He wrote in his field notebook, "They build not the gun, but the process of the gun." That insight summed up the central truth of the industrial war. The United States had not merely produced superior equipment, it had created an ecosystem of production so vast and integrated that reliability became automatic. Each M2A1 howitzer could be manufactured, assembled, and shipped in less than 3 weeks. The Germans, struggling under Allied bombing and material shortages, needed nearly 6 months to produce a comparable LFH-18M. By the summer of 1944, the U.S. Army possessed more than 10,105 mm howitzers in active service across Europe and the Pacific. Each American infantry division typically fielded 54 of them, organized into 3 battalions. German infantry divisions at the same stage of the war averaged 24 howitzers and often far fewer. Yet the difference was not simply numerical. It was cultural. American artillery units were trained to operate under what their doctrine called flexible control. Forward observers on the front lines had direct radio contact with gun batteries miles behind them. A single observer could call for fire from multiple batteries simultaneously, coordinating concentration fire within minutes. German artillery, by contrast, remained bound by hierarchy. Requests for fire had to pass through battalion or regimental command, a process that consumed precious minutes. Even when they achieved accuracy, they rarely achieved volume. The difference showed itself in Italy again and again. The Allied Fifth Army's records reveal that during the Cassino campaign, American artillery fired an average of 60,000 shells per day. The entire German 10th Army opposing them fired fewer than 10,000. To the men on the receiving end, those numbers were not abstract. They were sensory experiences, the whistle, the concussive shock, the endless rhythm of fire. Brenner's diary described one such moment during the retreat north of Rome, when his battery came under sustained American artillery for the first time. It began at 1700 hours. The first shells struck behind the ridge. Within minutes, the whole valley was a sea of dust. We could not distinguish individual explosions. It was one continuous roar. I counted perhaps 100 shells in the first minute. Then I stopped counting. That figure was not an exaggeration. A standard U.S. field artillery battery of 4 guns firing at the maximum rate could deliver more than 30 rounds per minute. Multiply that by the 12 batteries in a division, and the sky itself seemed to collapse. The M2A1's efficiency was not just a matter of firing speed. It was sustained by logistics of almost unimaginable scale. Each American infantry division consumed roughly 2,000 tons of supplies daily, of which nearly 1/3 was ammunition. The German equivalent division received less than half that tonnage in total, including food and fuel. Brenner's superiors began to issue new tactical instructions, acknowledging the imbalance. Avoid prolonged duels with American artillery, one directive from Army Group C advised. Change firing positions every 6 rounds. The enemy locates batteries by sound within minutes. The Americans had perfected sound ranging and counter-battery radar by 1944, allowing them to triangulate German firing positions with astonishing speed. At Verona, Koenig's engineers continued their examination. They fired the gun repeatedly, timing its rate of fire, measuring wear on the rifling, and testing recoil absorption. Their report concluded that the American gun could sustain 6 to 8 rounds per minute for short durations, with no mechanical degradation even after 200 continuous rounds. The Lef H-18M, by comparison, required cooling breaks after 100 rounds to prevent oil vaporization and recoil failure. But what most impressed the Germans was not the performance but the simplicity. The American manual, recovered along with the gun, was written in plain English with clear diagrams. Koenig translated one paragraph aloud to his team. "The gun is only as good as the men who serve it. Keep it clean, keep it fed, and it will answer every call." He smiled grimly. "It reads like a factory slogan," he said, "but perhaps that is why they win." The discovery unsettled him. Like many German engineers, Koenig had believed that the war would be decided by technological sophistication, jet aircraft, long-range rockets, armoured behemoths like the Tiger tank. Yet here was proof that a simple, durable tool, made by the thousands, could achieve more than the most advanced prototype. By July of 1944, copies of Koenig's findings circulated among Wehrmacht artillery commands. Some officers dismissed them, others quietly acknowledged their implications. In Normandy, as the Allies broke through the hedgerows after Operation Cobra, American 105mm howitzers pounded German defences with such frequency that survivors later described the ground as liquid. An officer from the Panzerlehr Division wrote, "The artillery fire is so dense that men believe they are under bombardment by hundreds of guns. Yet the prisoners say it is the work of only a few batteries. Their rate of fire is inhuman." It was not inhuman. It was industrial. When Brenner's depleted battery finally reached the Gothic Line in late 1944, he received a new assignment to form a composite artillery company using captured Allied guns. His Verona howitzer was among them. Ironically, he would now fight using the very weapon that had once shattered his positions. The Wehrmacht had no shortage of ammunition for these captured guns. Every retreat left behind abandoned Allied stockpiles. But they lacked spare parts and towing vehicles. Still, the captured M2A1S performed better than expected. Brenner later wrote that his men preferred them to their own Ley FH-18 seconds. "The American gun," he noted, "is lighter, easier to aim, and never jams. Our only problem is that we cannot match its ammunition supply." That last sentence summarized the war's arithmetic once again. For every shell Brenner's men fired, American gunners fired 10. During one-night action near the Apennines, Brenner's composite battery attempted to counter an Allied push across the Santerno River. They fired every round they possessed 60 shells per gun and achieved several direct hits. But within 20 minutes, Allied artillery replied with a barrage so massive that the landscape disappeared in flame. When the shelling ceased, one of Brenner's gunners, a young Bavarian named Huber, said softly, "It is not war anymore, it is production." Brenner could not argue. In that moment, surrounded by craters, he realized that the essence of modern war had changed forever. The soldier's courage, the officer's tactics, even the engineer's ingenuity, all were now secondary to logistics. The Americans called it the arithmetic of victory. General George C. Marshall, U.S., Army Chief of Staff, had written in 1942, "We must outproduce, outsupply, and outshoot the enemy until he cannot stand." It was not rhetoric, it was policy. The numbers tell the rest. Between 1941 and 1945, the United States produced more than 10 million artillery shells for the 105mm howitzer each month at its peak. German shell production for all calibers combined never exceeded 5 million. For every German gun barrel, the United States had 6. For every German ammunition train, the Allies had 10. The German High Command recognized the futility. In January 1945, General Alfred Jodl circulated a memo warning that artillery ammunition stocks were at critical depletion, with some armies down to 3 days' supply. Field units were ordered to save shells as one saves blood. American orders were the opposite. In preparation for the crossing of the Rhine, Allied commanders authorized what was called maximum expenditure. In one 24-hour period, U.S. artillery fired more than 1 million shells, a greater quantity than the entire German army possessed on the Western Front. Brenner's war ended near Bologna in April 1945. His last entry, written in a trembling hand, recorded his final observation: "The enemy fires endlessly. It is not hatred that drives them, but a system. We fight men, they fight with factories." After the surrender, he was taken prisoner and sent to a camp near Livorno. There, an American officer curious about artillery spoke with him. Brenner asked if he might see one of the new howitzers again. The officer obliged, showing him an M2A1 being used for training Italian recruits. Brenner walked around it slowly, touching the breech. The paint was still fresh, the markings crisp. It looked exactly like the one he had captured a year before, identical in every bolt and curve. He nodded. "It is as if the war never touched it," he said. The officer replied simply, "That's the point." The weapon had become a symbol of something larger, the industrial invulnerability of the United States war machine. Historians later observed that the 105mm howitzer was the backbone of the Allied advance from Sicily to Berlin. It fired in every major battle, from Normandy's beaches to the Ardennes. It supported infantry, tanks, and even airborne divisions. Its ammunition was standardized, its crews interchangeable, its accuracy legendary. After the war, captured M2A1s continued to serve in France, Italy, and even in some reconstituted German units within NATO. The Soviet Union, which had received hundreds through Lend-Lease, copied its design for their D-30 gun. The weapon Brenner had once seen as a curiosity became the template for post-war artillery across the globe. But the psychological legacy within the German officer corps was more complex. Many veterans later admitted that their first encounter with American artillery shattered a lifelong belief in German technical superiority. The war had taught them that perfection, pursued in isolation, could not compete with adequacy multiplied 1,000-fold. The irony was bitter. German military tradition, which had worshipped precision as a moral virtue, was defeated by a weapon that embodied the virtue of imperfection, simplicity elevated to power by sheer repetition. Friedrich Koenig, the engineer from Verona, survived the war and went on to work for Rheinmetall in the early 1950s. In an interview decades later, he recalled that first examination of the M2A1. "I realized then," he said, "that our craftsmanship was archaic. We built masterpieces that could not be replaced. They built tools that could be made forever." That sentence might serve as the epitaph for an entire generation of German industry. In the end, the captured American 105mm howitzer was more than a weapon. It was a mirror reflecting the war's essential truth that modern victory belongs not to those who design the finest instruments, but to those who can build enough of them to drown the world in steel. As Brenner's diary closed with the final line, "They fire as if they have endless hands," the echo of that machine-like rhythm remained. Each round fired from those guns was a pulse of an empire that measured victory not in courage, but in capability. And in the silence after the last barrage, amid the ruins of Europe, even the defeated could not help but marvel at the relentless arithmetic that had brought them to this end. The Wehrmacht's capture and subsequent analysis of the American 105mm howitzer in the late phases of the European campaign produced a number of formal reports, some of which survived in post-war archives. These documents, preserved in the Bundesarchiv Militärarchiv in Freiburg and in the United States National Archives under Captured German Records microfilm series T78 and T283, allow historians to reconstruct with precision the sequence of technical evaluations, logistical notes, and doctrinal conclusions that emerged from these encounters. The weapon in question, the U.S. M2A1 howitzer, redesignated M101A1 after 1953, represented the principal divisional field artillery piece of the United States Army throughout the Second World War. It had been standardized in 1941 and was produced in quantities exceeding 10,000 units by 1945. Its carriage, designated M2, used split trails and steel disc wheels fitted with pneumatic tires, permitting rapid motorized towing by the standardized 2.5-ton truck known as the Deuce and a Half. The total weight of the piece in firing position was 2,260 pounds, and its standard propellant charge allowed a maximum range of 12,200 yards. German technical intelligence first encountered the weapon in North Africa during 1943. Reports from Heereswaffenamt test sections in Tunisia noted an American field gun of approximately 10.5 centimeter caliber, short barrel, semi-fixed ammunition, and unusually high rate of fire. The German analysts at that stage did not have an intact sample. The first complete specimen was captured by elements of the 14th Army near Salerno in September 1943. It was subsequently transported to the Kummersdorf testing ground in Brandenburg, For detailed analysis under report designation Hua Proof 10, 43A, the Kummersdorf engineers recorded that the American gun achieved an average cyclic rate of 8 aimed rounds per minute under sustained crew operation, verified in controlled trials conducted between October 3rd and October 7th, 1943. For comparison, the German 10.5 cm leichte Feldhaubitze, 1/8 F/H-18, under identical conditions averaged 4 rounds per minute. The German testers noted that the superior American rate derived from 3 design characteristics: the single-motion horizontal sliding wedge breech, the fixed loading tray integrated into the recoil cradle, and the semi-fixed cartridge case, which allowed rapid insertion without separate powder bag handling. German analysts described the breech mechanism as robust and economical in motion. The report praised its machining tolerances and low susceptibility to fouling after extended firing, crediting this to the use of high-grade chrome molybdenum steel and precision surface hardening. Metallurgical samples were forwarded to the Krupp laboratory in Essen, where engineers measured the Brinell hardness at 320 on the breech block surface and identified the alloy composition as 0.45% carbon, 1.25% chromium, and 0.25% molybdenum. The corresponding German breech alloys averaged lower chromium content and were thus more prone to galling during high-temperature operation. The evaluation emphasized the American emphasis on manufacturing simplification. The Howitzer's carriage employed standardized automotive bearings, interchangeable with those of common U.S. truck wheels. German ordnance officers noted that the American concept of parts commonality extends even to artillery equipment, contrasting it with the German system, which required specialized components unique to each weapon model. A statistical annex calculated that the American production of the M2A1 required only 1,700 machine hours per unit, compared with 3,000 for the Le FH-18. A subsequent report produced by Heeresgruppe B's technical staff in northern France in early 1944 re-examined the operational implications. The field trials compared one captured M2A, one with a standard Le FH-18M, equipped with muzzle brake. The American piece fired 240 rounds of high-explosive M1 ammunition without mechanical stoppage. German crews operating the weapon remarked upon the ergonomic layout, particularly the use of hand wheels that could be operated from a seated position, and the recoil recuperator system that required minimal manual adjustment. One observer commented that the American weapon is engineered for speed of handling rather than for aesthetic perfection. From a ballistic standpoint, the German engineers recognized that the M2A1's shell, weighing 33 pounds, carried a slightly smaller bursting charge than the German projectile of the same caliber, but the rate of fire and consistency of fuse performance compensated for this deficit. Test data showed a dispersion of less than 25 meters at 7,000 meters range, equal or superior to the LFH-18. The report concluded that the tactical effect of the higher firing rate outweighs the marginally smaller shell weight when considering the American logistics of ammunition supply. The logistical comparison became a focal point of German analysis. Statistical intelligence compiled from captured documents revealed that the United States Army Field Artillery allocated roughly 1,000 rounds of 105mm ammunition per gun per month during active campaigns, whereas equivalent German allocations for 10.5cm howitzers seldom exceeded 300. Production figures from 1944 demonstrated the disparity. American factories produced nearly 23 million 105mm shells, compared to approximately 4 million 10.5cm rounds manufactured within the Reich and occupied territories. Captured American artillery manuals, particularly TM9-307 and FM6-40, impressed German evaluators with their clarity and standardized procedures. The manuals defined exact crew, roles number 1 through number 7, with each man trained to perform any other's task. This flexibility, combined with the weapon's mechanical simplicity, allowed sustained high-tempo firing even under combat stress. The German artillery system, by contrast, relied on more specialized roles and assumed a slower cadence for observation, command transmission, and range correction. Operational encounters further confirmed these laboratory findings. Reports from the German 7th Army during the Normandy campaign recorded repeated instances of concentrated American howitzer fire of unusual rapidity and precision. At Saint-Lô in July 1944, observers measured intervals between salvos of less than 15 seconds, concluding that the American batteries coordinated via radio and fired in time-on-target sequences simultaneous impact from multiple batteries across sectors. This was made possible by the uniform ballistic tables of the M2A1 system and the mass availability of radio equipment at battalion and battery level. Here is Group B transmitted a memorandum to the Oberkommando des Heeres on August 2, 1944, noting that enemy divisional artillery exhibits continuous readiness, as if supported by an inexhaustible supply of ammunition and spare barrels. The same document recommended the acceleration of Germany's own lightweight howitzer project, the Leutnant 18/40 on Park 40 carriage, in an attempt to match American mobility. Yet shortages of raw materials and transportation soon rendered such adaptations largely theoretical. Captured field pieces in the Ardennes during the winter of 1944 provided further material for examination. Technical officers of the 5th Fallschirmjäger Division recovered 3 intact M2A1s near Bastogne. Their accompanying after-action report, dated January 6, 1945, recorded crew impressions. The operation of the American gun is extraordinarily easy. With training, our men achieved 7 rounds per minute within 1 hour. The same report complained that German propellant charges for captured ammunition produced excessive chamber pressure, suggesting differences in cartridge case volume and primer strength. Ammunition analysis at the Hillersleben Proving Ground confirmed that the American semi-fixed cartridge design allowed 5 variable charge increments within a brass case, designated charges 1 through 7. The German propellant system used separate cloth bags with charge designations 1 through 8, requiring an additional step of insertion and thus reducing sustained rate of fire. The American design, though more expensive per unit due to brass use, simplified logistics and allowed partial charges to be extracted and reinserted quickly. By March 1945, as the front collapsed, the Heereswaffenamt circulated a classified bulletin titled Beurteilung Erbeuteter, Amerikanischer Feldhaubitze, M2A1, Evaluation of Captured American Field, Howitzer, M2A1. The memorandum's summary statement read, "The weapon represents an optimal balance between mobility, reliability, and sustained fire volume. It exemplifies the industrial mass production philosophy of the United States and the doctrinal priority placed on continuous fire support." The bulletin advised that post-war artillery design should study the simplification, breach operation and carriage maintenance demonstrated by the M2A1. Parallel to the official analyses, anecdotal field observations circulated among German front officers. Several captured diaries mention the shock of discovering the rate and intensity of American artillery fire. Oberleutnant Heinz Reinecke of the 26th Volksgrenadier Division wrote on December 19, 1944, near Wiltz, "We captured an intact American gun. In 10 minutes, our gunners fired 80 shells without stoppage. The hydraulic recoil system absorbed everything. It is incomprehensible how such output can be maintained on every sector." His entry, preserved in post-war collections, corresponded closely with technical data from the laboratories. Post-war Allied documentation corroborates the German assessments. The United States Army Ordnance Department's summary report on captured enemy studies, published in 1946 as Enemy Ordnance Materiel, Exploitation of Captured Equipment, acknowledged that German engineers had correctly recognized the manufacturing efficiency and field reliability of the M2A1. The report quoted fragments of German evaluations retrieved from Kummersdorf in April 1945, translating their conclusions nearly verbatim. In operational statistics compiled after the war, the U.S. Army Field Artillery Branch calculated that during the Normandy campaign, a typical battalion of 12 M2A1 howitzers fired an average of 65,000 rounds per month. Equivalent German battalions with the Leutnant averaged 15,000 rounds. The discrepancy stemmed from both logistical capacity and barrel life expectancy. American barrels were routinely replaced after 7,000 effective full-charge rounds. German replacement intervals extended to over 10,000 due to shortages, reducing accuracy. Industrial data underline the scale of divergence. Between 1941 and 1945, the United States manufactured approximately 10,500 M2A1 howitzers and 110 million rounds of ammunition for them. German production of all 10.5-centimeter field howitzers totaled less than 7,000 pieces, with ammunition output one-third that of the American total. These quantitative differentials translated directly into battlefield density. An American Infantry Division possessed 54 105mm howitzers. A German Infantry Division averaged 36 guns of equivalent caliber by 1944, often fewer due to attrition. The comparative analysis extended to mobility. The American carriage's pneumatic tires allowed towing at speeds exceeding 30 km per hour on paved roads, and even cross-country at 15. German steel-rimmed carriages, many still designed for horse traction, averaged less than 10 km per hour. Despite later conversions to rubber tires and motorized limbers, German artillery remained partially horse-drawn until the end of the war. The Kummersdorf engineers quantified that the American artillery arm is fully motorized from factory to front line, while Germany's remained constrained by fuel and vehicle shortages. The engineering cross-pollination that followed the war reflected the long-term influence of these findings. When the Bundeswehr was established in 1955, it adopted the American 105mm howitzer, M2A1, redesignated LFH, 18/40, US in early documents and later as PARS, the M101A1 in NATO service. German ordnance officers who had formerly studied the weapon under wartime conditions now trained on it as a standard piece within the new Western alliance. This continuity underscores the enduring technical merit of the design originally analyzed with such astonishment in 1943. Archival correspondence between Krupp engineers and British technical liaison officers during 1946-1947 demonstrates that post-war artillery development in Europe directly incorporated features of the Flaklee AR Ride of Lee-Teesing-Taylor. American system: simplified breech blocks, interchangeable carriages, and attention to mass production tolerances. These design philosophies contrasted sharply with the pre-war German preference for artisanal precision and non-interchangeable parts. The overall statistical picture by 1945 reveals the technological and logistical foundation underlying the shock experienced by German crews upon first employing the captured American weapon. The American artillery branch consumed nearly 26% of all U.S. munitions expenditure during the war, an industrial commitment unmatched by any Axis power. The field artillery became a symbol of mechanized coordination, with fire direction centers integrating survey data, weather corrections, and radio communications into centralized control. German artillery doctrine, though technically proficient, lacked comparable systemic integration due to communications shortages and decentralization. In summation, the German studies of the American 105mm howitzer revealed three fundamental insights. First, industrial standardization permitted an unprecedented rate of production and maintenance that the resource-constrained Reich could not emulate. Second, design simplification translated directly into combat efficiency, as crews could sustain 8 round-per-minute rates without mechanical fatigue. Third, the logistical depth of American system continuous ammunition supply, spare parts distribution, and motorized transport rendered tactical superiority in artillery fire almost inevitable, regardless of local skill differentials. These conclusions appeared in the final Heereswaffenamt synthesis report, dated April 12, 1945, under the title Schlussfolgerungen aus der Untersuchung amerikanischer Artillerie. The concluding paragraph stated, "The American 105 mm field howitzer exemplifies the war potential of an industrial state operating without material restriction. Its simplicity is deceptive. Behind it stands a production system whose scale renders traditional European concepts of craftsmanship obsolete." Post-war analysts within both NATO and the Warsaw Pact independently confirmed the durability of that assessment. The M2A1, under its M101A1 designation, remained in frontline service in multiple armies into the 21st century, a testament to the soundness of its engineering principles. The weapon that had once astonished German gunners by delivering 8 rounds per minute ultimately became an enduring artifact of 20th century military standardization. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.